Have you ever been in a situation where you changed one line of code and your entire program stopped working? I have been there, and I believe you have been there too. Uh, Today, we're going to talk about really interesting topic that is about loose coupling, and to talk about this really interactive topic and something that everyone can relate. We have Tural Suleymani. I hope that's how you say his last name. He's a senior .NET developer, very active in the community, C# Conda MVP, and we all love him there. So without any further ado, let's bring Thurul. Hi, Thurul. Welcome
Yeah.
to the show.
Hey, Simon, thank you very much for having me. How are you
Yeah,
doing?
I'm doing absolutely great, Thurul. Thank you for
Oh,
accepting the invitation. Finally we get to meet you, and
it's
finally
my
the
pleasure.
entire community gets to see how handsome Thurul is. Thurul, we're gonna do a
Sounds a
lot of
little
chit
bit
chat.
scary.
Thurul, we're gonna do chit chat towards the end of this session. I'm not gonna take much of time. I'll add your screen to the presentation, and I'll let you take it from there.
Exactly. Okay. In this session, we're going to talk about loosely coupling in software design. I think this is one of the important topics in software design. And for me, the software design starts from the high cohesion and loosely coupling. This is my personal opinion. Why? Because when you dive into details of software design, you're actually learning the loosely coupling and high cohesion in more detail. Okay, let's see what we have in our agenda. We'll talk about the roles of high cohesion and loosely coupling in software design, and of course, we'll dive into details of loosely coupling. There are a lot of forms of loosely coupling, but I will mention only the most important ones. Okay. So, first things first, let's try to understand first what is modularization. What is a software? A software is a problem. So, there is a problem, and we are trying to solve a problem using some sort of programming language, technology. So, we are building some sort of application. And we are trying to handle complexity in this application using divide and conquer principle. Okay, so we are dividing a complex software system into smaller, more manageable modules with clear tasks and boundaries. From the example of microservice, let me explain this concept. So we have this sort of microservice, and microservice consists from smaller services. Okay, and these services have their own bounded context. And when we are dealing with a big problem, we are trying to divide it into smaller tasks. So you can think about it like a small problem. Okay, right now we have three small problems, and in this case, every microservice may have more than one modules. Actually, they will have a lot of sub modules in there. Okay, so in this case, let's say this is our account microservice, this is our customer microservice. In customer microservice, we have 20 modules. Here we have 25 sub modules. So these sub modules should have tightly coupled relation between each other because they have one single bounded context and they have one huge reason to change. They are tightly coupled. This is the concept of high cohesion inside one module. But we need to communicate between these modules to have one single application, big application. Okay, in this case, we are trying to somehow, it doesn't matter, you're building a synchronous communication, asynchronous communication between these microservices. At the end, we are trying to have loosely coupled communication between microservices. Why? Because we need extensibility. We need to change these modules without depending with each other. Okay, this is how we are dealing with high cohesion and loosely coupling. In general, we have these loosely coupling elements. These are forms of loosely coupling. We'll start to talk about content coupling. Then we have a lot of other coupling stuff in this presentation. I just demoed that with colors that we have these 6 items. And first we'll start from content coupling and we'll end with data coupling. And in the middle, we have different sort of couplings. We'll talk about it. Okay. For me, the high cohesion and loosely coupling looks like union symbol. Okay, so you cannot create an application that is fully modular. There is no need to create fully modular application. Your application should consist from static and dynamic elements. This side, let's say, our static elements. This side are our dynamic elements. So they should live together to have a big application. This is how we are dealing with complexity. If you think to deal with complexity to make fully dynamic application, this is not correct. There is no need always to have interfaces, abstract classes everywhere if you're using C# language. So your application should consist from static elements and also from the dynamic elements. Okay, and loosely coupling. Loosely coupling is about unrelated things. So in our previous scenario, there was 3 microservices, and these microservices by itself, they are unrelated things. Yeah, of course, from the big context, they are related with each other, but in general, they are unrelated things. For example, customer is doing with customer things, customer business operations, order is dealing with order operations, so they are completely unrelated. It is possible for us just to grab this microservice and use in another context with other applications. Okay, so loosely coupling occurs between 2 modules, but high cohesion is inside one module. When you are building an application, you should take into account that you should create loosely coupled relation between elements, that these elements are unrelated elements. So loosely coupling is about unrelated things that should change independently. And of course, there are tons of benefits of loosely coupling, high cohesion. Let's talk about the benefits of loosely coupling. It helps us to increase maintainability, improve reusability. From the scalability perspective, is really good to use loosely coupling. And of course, it provides us a greater flexibility. I don't want to talk much about the theoretical stuff. You can find more information on internet, but let's focus on the practical stuff. Okay, let's talk about the loosely coupling for the elements of loosely coupling. First one is our content coupling. This is really important to understand. It doesn't matter if you are a junior developer, middle developer, double middle, triple middle. It actually doesn't matter. If you are a software architect, you should understand this concept, high cohesion and loosely coupling, to write a better code. This is really important. Okay, so what is the content coupling? This content coupling occurs when different modules, let's say we have 2 modules and we want to communicate with each other, they want to communicate with each other, and we are directly referring and manipulating to the second module's internal data or implementation details. Okay, so you should encapsulate your logic, and you shouldn't provide your other modules to directly interact your module's data structure, internal data, and implementation details. This is a simple example here. For the content coupling, we have, for example, some function here. Okay, and we have calculator at a class. I will show you the example from the C# perspective, but if you know C#, Java, doesn't matter, they are high-level language, so you should feel confident with these examples. In my case, what I'm trying to do, I'm trying to calculate first number and second number and set result to calculator again. This is a huge problem because the responsibility of calculator is calculate, but you're another method trying not to delegate, but directly calculate and set results. So you are referring to internal data. This is our first number, second number is our internal data. They are just properties, but you are directly referring to the result. The calculator should encapsulate the calculation logic and should not provide you to set data like this. In this case, you should just delegate. You see, we are just delegating the responsibility to calculator, and we are getting result from calculator. That's how it should be. Okay, that's how we are going to avoid this content coupling problem. And we also have in Visual Studio, we have a second example here. I've created a lot of interesting examples for you. So let me just open an example here. So this is just simple cart class. Okay, there is no business logic right now. What I am trying to do, I'm just trying to, for the cart number, I'm trying to assign some number. As you can see, this is not a valid number. But in my case, for my cart, I have gettern and settern, and you may think that if you have a getter and settern, it means you are already encapsulated data, but this is not an encapsulation, and your class provides us ability to directly set invalid data. We should avoid this, and we need to have additional encapsulation, additional protector over our number, not to allow this type of data. Sorry. So this is also going to be our content coupling in this case. Okay, the second form is common coupling. We have used this common coupling everywhere when you use enums, when you are dealing with static variables. So the common coupling refers to a specific type of tight coupling where multiple modules within a program share access to the same global data. Of course, in .NET, we have global data concept, but it was implemented in ill language. But in C#, we have static variables that we are going to use as a global data. Let me show you one example here. So in my case, I have, let me just close this, okay. I have user session, and this user session has the user ID. This is a static property, okay. And my logger service is directly using this user session's user ID. The problem here is right now I have tightly coupled between logging service and user session. This is a huge problem. When I want to change this logging sessions, it has direct dependency from user session. So it is not possible for me to change user session confidently. This is a big problem. So you need to avoid it. This is a common coupling. Okay. So you have this shared data among your modules, user session model and logging model. You need somehow to avoid it, and using some sort of abstraction using interfaces, abstract classes, some other techniques, you can easily do it. Right now I have user ID provider as an interface, and my user session inherits from a user ID provider. And in my case, logger service doesn't interact with user ID directly. I have dependency from the contract rather than implementation. And it helps me to easily change logging service, and I can easily change the implementation because I have dependency from abstract element, not the concrete element. This is how we are resolving this common coupling. Great. So the third one is going to be our external coupling. I think this is one of the interesting subtopics for loosely coupling. I will tell you one simple example here. When you are using entity framework directly in your application, it means you have external coupling because this is a third-party library. This is a different module, and your application directly depends your entity framework. This is one of the reasons why people uses repository layer over entity framework, but entity framework by itself is also a repository with unit of work. But let's talk about external coupling. External coupling refers to the interdependence of different modules based on factors outside the system itself. So in a simple manner, modules relying on a third-party library with known limitation. we already know that entity framework has its own limitations also. The limitation is not a fact here. So the problem here is you are depending from some third part library. Okay, we have a lot of other examples, like an application reading product data from a specific data format, code interacting directly with specific hardware devices. So you have some sort of dependency from the implementation, okay, rather than the abstract element. In my case, let me show you one example here. This is our customer service, and my customer service depends from customer DB context. So actually this customer DB context, as you know, the inherits from DB context. DB context is my entity framework DB context. So we have direct dependency from entity framework. And how you can deal with that, if you really need to isolate your application from entity framework, it doesn't mean that if there is external coupling, it is bad, let's try to avoid it. No, it depends. I really love the term "it depends" in programming, because it really depends. In your case, the common coupling also may be okay, completely okay. So applying content coupling, common coupling, external, not content coupling, but common external control, stamp coupling, actually depends from your applications, from your requirements. In my case, I have the customer service that depends from the entity framework DB context. If I want to isolate my application from entity framework, of course, I will use additional abstraction, like abstract classes, interfaces, etc., additional abstraction using repository, etc., to isolate my application from entity framework dependency. Okay, that's how we should deal with external coupling. Of course, not just external coupling, but it is applicable for all sort of couplings. If you need to avoid some sort of coupling, we are always trying to add one more abstraction over it. This is one of the way of dealing with the issue. And of course, the other one, the a little bit tricky one, is going to be our control coupling. It is also called tell, don't ask principle. Okay. Instead of focusing on external factors, control coupling deals with how modules influence each other's execution. So you have two modules, and one module dictates the flow of other module. This is a big problem. There is a boss who dictates that this model should do like this. For example, if you have if, else, switch case type of things in your application, and one module dictates how other module should behave. This is about our coupling also. Let me show you one example from control coupling here. For the control coupling, I have, for example, order processor. In this case, I have two important modules, order processor and order. Okay. And order processor is going to be our boss, the leader. And the worker is going to be our order. And you see we have is priority, Boolean indicator, a flag. So one of the important signs of showing that there is a control coupling in your application, there should be some sort of flag that indicates that one module manages another. Okay. In my case, I have a Boolean indicator here, and depending this Boolean value, I have two type of flow for my order. It means my order is not a fully functional, is not independent module. There is someone who dictates the rules. This is a big problem in our application. So how to deal with that? Of course, we have a second version here. Again, we have additional abstraction using interfaces, abstract classes. Even using simple class is also abstraction. So the class is abstract data type. So it is also abstraction. In my case, we have iOrder handler, okay, for order, handle order, and we have two implementations. Instead of having Boolean indicator with two flows, I have two different implementations here, and I'm injecting directly the flow itself rather than allowing order processor to define the path to dictate the execution path for my order. This is a little bit tricky, and the other coupling is going to be our stamp coupling. Yeah, I think we're all faced with this coupling. The problem here is, let's say you have some sort of a method, okay, and your method accepts 6 arguments, let's say. I don't know, 4 arguments, 3 arguments, but you are usually using only 2 of them, 1 of them. It means you have a lot of arguments, or you have one complex argument. Let's say you have a method that accepts order class as an argument, but you are using only 2 or 3 properties of this order instead of having another complex data or multiple small sort of arguments. You are dealing with a huge complex data. Okay, the problem here is, in your case, we have 2 modules are stamp coupled if they communicate using a single data structure. Let me show you the example here. So in my case, we have order service, and order service has send order confirmation email, and we have customer as an argument. The problem here is, as you can see, I'm using only name. This is only a requirement for me. Instead of directly accepting string name, I'm using customer because it is easy for me. I don't want to spend more time just typing string name. I'm just using the customer, and I'm trying to make some sort of reusable code, but there is nothing to reuse. This is a bad habit. You should provide the exact arguments you're using. So if you have 2 arguments, you should exactly use them. In most cases, for the in all .NET platform, for example, for platform invocation or all that type of elements, you may say that there is a method that accepts 15, 16, 10 arguments, and most of them are just nulls. Okay, this is also a problem of stamp coupling. You need to provide only the exact argument count that you are using. If you need to, for example, name, surname, just provide name, surname instead of providing the customer that consists from 10, 11 properties. And how to deal with that? This is also obvious. We have I order confirmation data. This is one of the form of dealing with this issue. The other one is just doing like this. Oops, let me just copy, paste. So if you are dealing with just name and surname, just provide string name and string surname. That's all. And this stamp coupling provides a way for data coupling. The stamp coupling is actually a one form of data coupling. Okay. The data coupling refers to the degree of interdependency between different modules based on the data they exchange. It means you have the exact arguments you need to use. In my case, I did a little bit refactoring here, and now I have exact coupling called data coupling. Okay, that's how we are dealing with this problem. As I mentioned, it's really important. It doesn't matter if you are going to be a software architect or if you want to be a senior engineer. You should start to learn the basics. For me, this is also basics of software development. This is, of course, related to software design, but this is a basics of software development. So every developer, if you are a junior developer, middle developer, senior, it doesn't matter. We are using these elements in our daily basis. So you should know the loosely coupling and high cohesion principles. And thank you for watching. That's all about this session.
Well, that was great, Dhruv. Thank you so much. I believe you taught so much about loose coupling. I never knew it so much existed. And I
Thank
would
you.
encourage everyone to go ahead and check the video description. You'll find Dhruval's all social handles. And also, he has recently published a new Udemy course. You should also go and check out. You'll find all the details on his LinkedIn. Thank you so much, Dhruval. Thank you so much for this great session. And thank you so much, everyone, for watching. We will see you
Thank
in the
you.
next episode at dashboard.net. See you.
Thank
Bye
you.
bye.